Welcome back to the Python Pandas series. In the last video, we explored the Pandas series, that 1D labeled array which acts as a fundamental building block. If you haven't seen that yet, the link is in the description. Today, we're moving on to the star of the show, the data structure you'll likely spend most of your time with in Pandas, the DataFrame. This is the workhorse for handling tabular data in Python. By the end of this video, you'll understand what a DataFrame is, several ways to create one, and its basic attributes. Let's dive in. So what is a Pandas DataFrame? Imagine a spreadsheet or a database table right inside your Python environment. It's a two-dimensional, size-mutable, potentially heterogeneous tabular data structure. Let's break that down. Two-dimensional. It has both rows and columns, size-mutable. You can add or remove rows and columns. Heterogeneous. Unlike a typical NumPy array, the columns can hold different data types, like numbers in one column, text in another, dates in a third. Labeled axes. Both the rows, the index, and the columns have labels. Crucially, you can think of a data frame as a collection of Pandas series that all share the same index. Each column in a data frame is actually a series. Let's see the most common ways to create a data frame. As always, start by importing pandas. First, from a dictionary of lists or NumPy arrays. This is very common. The dictionary keys become the column names, and the lists or arrays become the column data. All lists/arrays must have the same length. See? call_A, call_B, call_C are our column names. Pandas created a default integer index 0, 1, 2, 3 for the rows. Second, from a list of dictionaries. This is useful if your data comes in record-like structures. Each dictionary in the list represents a row. Pandas automatically infers column names from the keys and handles missing keys by inserting nan, not a number. Notice Bob's row has NaN for city, as it was missing in his dictionary. The extra key from Charlie's dict became a new column, with nans for the other rows. Third, from a 2D NumPy array. If you have data in a NumPy array, you can turn it into a data frame, but you usually need to specify the column and index labels. Fourth, from a dictionary of series. This clearly shows the relationship between series and data frames. Pandas automatically aligns the data based on the index labels. Since D only existed in series_Y, series_X gets a nan value in that row for column X. Just like with series, the index is crucial. In a data frame, you have labels for both rows and columns. You can access them directly. df.index gives you the index object for the rows, and df.columns gives you the index object holding the column names. Data frames have several useful attributes to understand their structure. .dtypes is important. It returns a series showing the data type of each column. .shape gives you the dimensions, rows, columns. .values extracts the data as a 2D NumPy array. .size tells you the total number of cells, and .ndim confirms it's two-dimensional. Now that we can create data frames, how do we quickly look at the data inside, especially if it's large? We'll cover this properly in the next video, but here's a sneak peek. .head shows the first few rows, .tail shows the last few, and .info gives a concise summary including the index type, column types, non-null counts, and memory usage. These are vital first steps. So there you have it, the Pandas data frame. We learned it's a 2D labeled table, like a spreadsheet in Python. It's built from series sharing an index. We saw several ways to create one, from dicts of lists, lists of dicts, NumPy arrays. We reviewed its structure, rows, index, and columns. And we looked at key attributes like dtypes, shape, values, index, and columns. The data frame is central to almost everything we'll do next. In the upcoming video, we'll focus on the essential task of loading data into data frames directly from files like CSVs and Excel, and then properly inspecting that data using functions like head, tail, info, and describe. Practice creating data frames. Try different methods and explore the attributes. If this video helped, please hit that like button and subscribe so you don't miss the rest of the series. Thanks for watching, and see you in the next one.